Welcome to my presentation on zeros of an analytic function. This presentation contains definition, few examples and some results on zeros of an analytic functions. Definitions. Let f of z be a function which is analytic in a region D and a point A belongs to D, then A is said to be a zero of order R for f of z if f of z can be written as z minus a power r into phi of z, where phi of z is analytic at A and phi of A not equal to 0. 0 for f of z is said to be isolated if there exists a neighborhood that does not contain any other 0 for f of z. Now we consider few examples for finding zeros of given functions. The function sin z can be written as z into 1 minus z cube by 3 factorial plus z power 5 by 5 factorial minus etc. Here we take phi of z as 1 minus z cube by 3 factorial plus z power 5 by 5 factorial minus etc. Phi of 0 is not equal to 0 and z minus 0 power 1 we have. So 0 is a 0 of order 1 for this function. Next function is z minus 2i the whole square into z plus 3 cube into e power z. Here we will take phi of z as z plus 3 cube into e power z. Phi of 2i is not equal to 0 and z minus 2i power 2 we have. So 2i is a 0 of order 2. Similarly, we can take phi of z as z minus 2i square into e power z. Phi of minus 3 is not equal to 0 and z minus of minus 3 power 3 we have. So minus 3 is a 0 of order 3. Next function is z square into sin z that can be written as z cube into 1 minus z cube by 3 factorial plus z power 5 by 5 factorial minus etc. Phi of 0 is not equal to 0 and z minus 3 power 3 z minus 0 power 3 we have. So 0 is a 0 of order 3 for this function. Next function is z cube minus 1 by z cube plus 1. This can be written as z minus 1 into z square plus z plus 1 into 1 by z cube plus 1. So 1 is a 0 of order 1 and this z square plus z plus 1 can be written as z minus of minus 1 plus I root 3 by 2 into z minus of minus 1 minus I root 3 by 2. So these two are also zeros of order 1 for this function. Next, some results on this topic will be discussed. The first one is, suppose f of z is analytic in a region D and is not identically 0 in D, then the set of all zeros for f of z is isolated. For proving this, first we take one arbitrary 0 for f of z whose order is r. Then we can write f of z as z minus a power r into phi of z. This phi of z is analytic at A and phi of A not equal to 0. Once phi of z is analytic at A, then phi of z is continuous at A because phi of z is differentiable at A. Now we use the epsilon delta definition. So there exists a delta greater than 0 such that modulus of z minus a less than delta implies modulus of phi of z minus phi of a less than modulus of phi of a by 2 for a given epsilon modulus phi of a by 2. Now we want to prove that this A is isolated. Suppose A is not isolated, then we can find another one 0 in this neighborhood z minus a less than delta. We take that 0 as B, which is not equal to A. Since B is another 0 for f of z, so we can represent b minus a power r into phi of b equal to 0. and b not equal to a, so b minus a never be equal to 0, so only possibility phi of b equal to 0. Further, b belongs to this neighborhood of a, so the distance between a and b is less than delta once any point whose distance from a is less than delta, that satisfies this condition. So phi of b minus phi of a less than modulus phi of a divided by 2. But modulus of phi of a is less than modulus of phi of a by 2 because phi of b equal to 0, which is not possible. So we get a contradiction to the assumption that b is another 0 for f of z in this neighborhood. So we proved that a is isolated. Since a is an arbitrary 0 for f of z, hence we proved that the set of all zeros of f of z is isolated. Next result, that is corollary to the previous theorem. Let f of z be analytic in a region D. Suppose f of z is equal to 0 on a set of D which has a limit point in D, then f of z is identically 0 in D. For proving this, we assume the negation of the statement which we want to prove. That is, we take f of z is not identically 0 in D. Here we collect all the zeros for f of z and we call that as D dash. Obviously D dash is subset of D. By the given hypothesis, D dash has a limit point in D. We just to take one limit point of D dash and we use the definition of limit point. D dash difference A intersection n of A is not equal to 0 for every neighborhood of A. From this we can find more than one element of D dash belongs to n of A. Hence D dash has 0 which is not isolated. By using the previous result, we get a contradiction. So f of z is identically 0 in D. Next corollary, f of z be two analytic function in a region D. Suppose f of z equal to g of z on a subset of D which has a limit point in D, then f of z is equal to g of z in D. For proving this, we just take h of z is equal to f of z minus g of z and apply the above corollary for this function. We get f of z minus g of z is equal to 0 in D. So f of z is equal to g of z in D. Hence we proved this corollary also. Thank you.